Hello everyone. While glucose is historically blamed in the pathogenesis of type 2 diabetes, today we're going to discuss saturated fat's causative role. For the purpose of this discussion, we're going to focus on two organs. The pancreas is responsible for insulin secretion, which is used by the liver to maintain glucose homeostasis. Recall that in the fed state, the liver is responsible for increased glucose utilization, and in the fasted state, the liver is responsible for glucose production. Glucose utilization or production is regulated by the hormone release from the pancreas. The American Diabetes Association summarizes type 2 diabetes as a problem in which the body does not use insulin properly, resulting in high blood glucose. However, prior to the manifestation of hyperglycemia in type 2 diabetes, there's already dysregulation of fat metabolism and insulin resistance. In fact, this is what contributes to hyperglycemia and the symptoms of type 2 diabetes. So let's first begin with the pancreas. Beta cells sense the change in glucose and release insulin in response. This glucose-stimulated insulin secretion starts when the ATP-sensitive potassium channels are triggered and increase the cytoplasmic calcium. Insulin granules are released from a pool near the plasma membrane. The beta cells can do this for about 10 minutes, followed by a second release from a reserve pool that follows the same pathway but releases a little bit less insulin. So saturated fats have a specific action on beta cells. Long-chain fatty acids can inhibit insulin biosynthesis and secretion. Not pictured here is the ability of saturated fatty acids to decrease DNA binding activity. Palmitic acid can inhibit expression of transcription factor PDX1, which is involved in cell differentiation into beta cells. GLUT2 transporters can also be inhibited, and saturated fats can cause a decrease in acetyl-CoA carboxylase expression. So here we start to see how both glucose metabolism and fatty acid metabolism are disrupted. The results here are hyperglycemic conditions. As a result, the beta cells try to compensate and release more insulin, resulting in both hyperglycemia and hyperinsulinemia. This can eventually lead to complete beta cell loss. As mentioned before, fat metabolism is altered by saturated fats, and this disordered fat storage and mobilization play a role in the pathogenesis. Normal lipid metabolism means that the lipids broken down from the diet are absorbed and digested in the gut and delivered as chylomicrons into adipose and peripheral tissues before returning to the liver as remnants. Here the liver can repackage these remnants with triglycerides and send them back out into tissues. Dietary fatty acids are metabolized and enter that pool in the liver. However, saturated fatty acids are less easily oxidized. This increases the hepatic exposure to non-esterified fatty acids. While these can be used to synthesize triglycerides, when this pathway becomes saturated, the liver cannot secrete the VLDL, and it begins to accumulate in the liver. In fact, in a study by Kotronin, they found that the liver fat content was 80% higher in type 2 diabetics, in contrast to the control group that was not diabetic. You can see here pictured that there's actually deposition of fat into the hepatocytes. Normally, the liver would produce glucose in a fasted state, such as overnight. And in response to insulin in the morning, hepatic glucose production would decrease when someone eats breakfast. However, this increased liver fat causes dysregulation to glucose homeostasis by disrupting insulin signaling, which results in continued hepatic glucose production, leading to even higher blood sugars. The liver is also responsible for clearing about 80% of the insulin from the blood. So as the fat accumulates in the liver, insulin clearance is impaired. Hepatic insulin sensitivity is affected by the high insulin levels. These two factors are what contribute to the hyperinsulinemia. Non-alcoholic fatty liver syndrome is increasingly common in type 2 diabetics. It's also important to note that this lipotoxicity causes the fatty liver to produce those very triglyceride-rich VLDL molecules That results in an increase in serum triglyceride concentrations and a decrease in HDL concentrations. It's important to consider these because these are two additional criteria common in a metabolic syndrome diagnosis. It's worth considering another hormone's involvement in this process. Adiponectin is secreted by adipose tissue and has an inverse relationship to body fat. The greater amount of body fat, the less adiponectin. This hormone helps to regulate glucose and fatty acid catabolism. It increases fatty acid oxidation and kind of regulates metabolism through increasing energy expenditure. This serves to increase insulin sensitivity and have a protective effect against insulin resistance. There's a really interesting mechanism that's also involved that should be considered when thinking about how saturated fatty acids can impact type 2 diabetes. Ceramides are long-chain fatty acids that are bonded through an amide to an amine substituent. Ceramides have a physiological role in mediating intracellular signaling. They serve as a second messenger. And studies have found that high intakes of saturated fatty acid cause an increase in free fatty acid concentrations, and that these ceramides then accumulate in the liver and interfere with insulin signaling. It's important to consider the effects saturated fatty acids are having in the pathogenesis of type 2 diabetes. A study by Hernandez in Germany in 2017 actually found that there was an increase of hepatic triglycerides, an impairment to hepatic insulin sensitivity, and an increase in hepatic gluconeogenesis with a single dose of palm oil, which is a saturated fat. If you think about the effects that a single dose of saturated fat can have on energy metabolism and insulin resistance, you then really have to think about what happens when you're constantly consuming these saturated fats. While it might seem easy to blame glucose, since type 2 diabetes seems like an issue with glucose metabolism, saturated fats really play a strong role in the pathogenesis of type 2 diabetes. They disrupt insulin production and secretion in the beta cells. They also impact insulin signaling. As they get into the liver, they alter lipid metabolism. They affect how lipids are stored and mobilized, which also has an impact on glucose homeostasis. These two are really tightly linked because they have a lot of common interchangeable metabolites. These are just 4 mechanisms that can be implicated in the relationship between saturated fatty acids and type 2 diabetes. Yet these 4 mechanisms demonstrate that saturated fatty acids cause the initial dysregulation to insulin production and secretion, dysregulation of that signaling through the accumulation of ceramides, and that once lipid metabolism is altered, the resulting change is the alterations in glucose homeostasis. Therefore, I would say that saturated fats are implicated as the beginning pathogenesis of type 2 diabetes. This has been recognized by the fact that there's more and more emerging research relating saturated fats in the diet to type 2 diabetes. The bolded references are original research demonstrating the relationship between saturated fatty acids in the diet and type 2 diabetes, and are the sources of information from this presentation.